So, I'm going to answer the question of why we don't lose our air or atmosphere to the vacuum of space. I'm going to first present what someone's position on why it doesn't make sense that we have an atmosphere with the vacuum of space, that there needs to be an explanation of that, possibly a barrier in between the vacuum of space and the atmosphere that prevents the air from leaving. So that person's position is going to be presented first. And then after, this next person is going to have a position of explaining why there doesn't need to be a barrier and the reason why we don't lose our air from the vacuum of space, which the answer will be there's not much pressure up there to lose a significant amount of air. And also the second person will be explaining what like a vacuum means and some stuff that you might not have thought about, and present some real world evidence of like a hole in the International Space Station, and someone plugged it with their finger. So let's watch this clip right now. I'm going to open up this to make this bigger. I think this will be better. Let's see if you can hear it. So this is the first person.
Number 2, vacuum versus gravity. The force of a vacuum is measured in units of torr, T-O-R-R. Even a low-level vacuum can overcome gravity here on the surface. In building molecule-free chambers for the manufacturing of electronics, a series of massive pumps are needed to create a 99% vacuum. That's -9 torr. And for the remaining 1%, horsepower isn't enough. It can only be achieved by a chemical leaching process. That being said, how is the -10 torr vacuum force of space not ripping off the atmosphere of this world?
This one's a common mistake made frequently by flat earthers. Vacuums don't suck as a rule. If you have a small vacuum here on Earth and you poke a hole in the side of it, then yes, air will rush into the container. Now, that's not because the vacuum is sucking the air in, it's because the higher pressure outside the container is forcing the air into a space where there's no pressure. It's why the astronauts on the ISS could easily plug that hole with their finger. They're fighting pressure of 1 atmosphere inside the spacecraft. The gravitational pull of the Earth keeps the atmosphere clinging to the planet. This means that the atmosphere has a pressure gradient. Think of the ocean. Just below the surface, there is very little pressure. However, as we go down deeper, the pressure increases. At 1 kilometre down, the pressure is just over 76,000 torr. This is because of the huge volume of water above. At 500 metres depth, the pressure is just over 38,000 torr, because there is less water above this point than at 1 kilometre. This is demonstrated well by placing 3 holes down the side of a full water bottle. The slightly greater pressure of the water at the bottom, due to all the water on top of it, pushes the water out of the bottom hole at a greater rate than the other 2. Now it's the same with our atmosphere. The atmosphere is also a fluid, like the sea. Here at sea level, the pressure is greatest because of the huge volumes of atmosphere sitting above us. About 760 torr. 1 kilometre up, the pressure is 676 torr, 5 kilometres, 433 torr, and so on. The edge of space is considered to be around 100 kilometres up. Pressure there is 1.5 torr. Because there's very little air pressure up there, there's no force pushing the atmosphere into space. Having said all of that, we do actually lose atmosphere to space, but that's got nothing to do with vacuums and everything to do with solar activity and the magnetosphere.
Okay, so that thoroughly answers why you don't lose air molecules to the vacuum of space. This is what's on record right now. This is the top explanation for why we don't lose air molecules. It completely makes sense. The evidence is being presented logically and reasonably. Where is the evidence faulty, or what is wrong with this explanation?